So here I'm just going to construct the squaring of the circle as it was meant to be. Well, I mean the ones okay, that we already know that a good majority of people deny being something of correctness, but I'll show you that it is of correctness. Trust. So um, I want to make sure okay, that this is centered because sometimes again if I well even if I don't do it centered, even again if I don't even like calculate the numbers, the pi ratio from the construction itself will yield exactly the same, so we don't really matter about that. But I'm just going to make it simple so that in this way we can see what I'm talking about. We all know that if we take the radius of the circle, the radius of the circle, we said okay, that we're going to put it as 1. Okay, so that's established. Perfect. I forgot to put the lines so that in this way okay, this remains stable. I'm just gonna remove the grid because we won't need that anymore. And then let's start with the construction. Now there are two constructions that I can do. There is one okay, which was devised by certain Samuel Leboy, which is the one which I'm going to do first. And then there's another one which is simpler, however, shortens the size of the no, increases the size of the circle short and keeps the size of the square exactly the same. So in other words, okay, what I'm saying is that the first one will yield a greater circle than the second one. Let me show you. So that's like the configuration of Samuel Laboy. He, he does like another circle, creating a Vesica Pisces, and creates a third circle so that when he creates like a triangle, the triangle is of 1, 2 by 1, which the hypotenuse gives us the square root of 5. Yeah. And we all know that from the square root of 5, we are able to find the golden ratio. So here, that circle, if we're looking at it, it shows like the one portion like for the golden ratio. Basically, that's the square root of 5 minus 1 at the bottom. Um, you don't see it right here. That's square root of 5 minus 1. Yeah. Then after that, we can remove these circles, and as a matter of fact, we can even remove the triangle right here. We don't need them anymore. All we need to do is just construct the triangle, because yes, there's a triangle that is involved in that construction, which unfortunately I haven't figured out yet how to construct on Desmos. So I'm just going, well, no, it's not true. I know how to construct it on Desmos, but only one portion of the triangle, not the full portion as it is shown right here. That's a full portion of the triangle. The only portion which I can do on Desmos, if ever like, come on, if ever I was doing it like directly on Desmos, then the only thing that you would see would be that portion right here when I use the polygon function again in order to create that. But I'm going to remove that and we're going to continue. Next, we need to create the square, and the square depends on the triangle which is right there. So we start with a circle right here and we do 4 more in the surrounding in order to create the square right there. Yeah. And then I just need that thing right here, like that. And here we have the version of Samuel Laboy of the squaring of the circle, which looks like this. If we're looking at the circle remains one half of the square, one half side of the square is the reciprocal of the square root of the golden ratio, as you can see right here where it says 0.786151, you know. And for the triangle, I haven't figured out that portion yet, but once I do, I'll let you know. Just to let you know, okay, I'm not mathematically inclined. I'm just a math hobbyist. I don't do this like on a daily basis. It's really just that it's in my mind, it's in my head, and it seems that it's important. I need to talk about it. That's what it is. So, if I were to take like for the Pythagorean theorem, you know, this construction yields the Kepler triangle. It will produce a Kepler triangle. Same angles everywhere, you know. If I'm taking these off and keep these, this shows a length of, you see, that's the square root of phi. This here is 1. This here is the reciprocal. This here is the square root of 5 minus 1. That obviously that's, I was about to say obviously that's something that so close to what I was looking at, but what I'm looking at again is half of pi, and the hypotenuse being 2. That is the truth. That is what the truth is all about. If I were to take that portion right here, multiply it by 2, that's pi. That's the real pi. That's the real pi. Now, if I were to, god damn it. I forgot I was doing a triangle divided by 2. Okay, so if I were to erase all of that, do a new one, and do my own configuration. From my own configuration, it's still using the number 1 as the number 1 as the radius of the circle. My configuration is a little bit easier. However, due to the fact that it's a little bit shorter, some people would say it's not accurate, but the accuracy is right there. It's just a shift in the size. It's nothing serious really. And the configuration starts exactly the same, you know, with the Vesica Pisces. However, I create a circle from the center of the Vesica Pisces, you know. And that's like normally the start when you would create a star. If you know how to create a star, well, good for you. If not, okay, I might show you on another video. But there are so many videos, okay, like showing you how to create a star. There's one on Metallurgy, I don't know if I pronounced this correctly, where it shows how to create the star, explains what the golden ratio is in relation to that star and whatnot. So, I mean, I invite you to watch this. And so, let me just continue. Like I said, it's all centered and all that. Then from there, I put a line from the base of the first circle to the center of the small circle right here. And then I create a bigger circle, which will be like the circle. So that circle, which I call D circle, is square root of phi. And the construction again is still very well done because here it reveals everything. You know, it reveals that it reveals the golden ratio right here and the square root of the golden ratio right here. And it really just reveals perfection right here, you know. So that's what you see. Then for this portion right here, what do we need next? Well, of course, we don't need that. We don't need that. We don't need that anymore. We don't need that. We don't need that. All we need is the circle at the center right here so that we can create 4 more circle and create the square right there. I'm just going to remove the grid because this is going to piss me off. And then we do the square. Boom. Remove the excess. And we add the triangles. So this one right here. And this one right there. Yeah. We can remove this. We can remove that. Do I need the other triangle? No, because you already know, okay, it's in there. So I'm not gonna put it. It's a waste of time. Remove that, and observation. Boom, square. The golden ratio. Wow. Number 2, nice. Number 1, yeah. Half of pi, again, the same one. And when I say the same one, this is no joke. Times 2 pi. You see that? And from there, okay, you have as a radius, 2 times the square root of the golden ratio. No, not the radius, I mean the diameter. But the radius is, wow. You see? And so, hence the reason why when I'm on Desmos and I do like the Pythagorean theorem and I do all these equations, I know, okay, that the correct pi is 3.1446 because basically it's constructible. You know, you can try to construct it with the same templates, okay, which I just did, the ones from Samuel LeBoy on my own. Like in real life, it will work. I have tried it numerous times, even wrote it down again on paper in my own notebooks. It works. It just does. The other pike which we're using, which like some of the kid genius like to memorize and whatnot, is wrong. And it makes me wonder if they're really geniuses. Because on the real, it's question of balance, observation. It's nature right in front of you. Y'all keep on saying like that, the pyramids, they're a mystery and whatnot. Well, maybe that's the key to the mystery, and maybe you need to open your eyes just a little bit more. I'm not trying to be condescending right here, but you're forcing me. Just observe. Just do your due diligence. Observe. Look this up. Try to do the calculations. Like for me, the only equation which I know is a fact is that one where R is the radius and S is like half the side of the square. And then I take the radius square plus S square root the radius square minus S square. And I'm so sorry, okay, like for the way that I'm writing this. Okay, I'm writing this with my fingers, so yeah, it looks horrible. And just make sure, okay, that you put the parentheses because bed mass is very important, you know. And that X right here will always give you the correct pi. Always, 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 always the correct pi. It cannot be anything other than the correct value of pi being 3.144606. Do your due diligence, research, because in the next 4 years, you might not have the chance to do that research anymore. And we might go back again to what some would call the Stone Age. So think about that carefully before you try to do anything like any engineering stuff, any invention which pi is in it. You might probably want to recalculate everything, and you might be surprised. You might find like some things okay, that you might have obviously forgotten or like did not input or something like that. I don't know. Just look this up. You know, I've done my work. Do yours. Peace out.